through the midpoint M of the side CD of a parallelogram ABCD. The line BM is drawn intersecting AC in L and AD produced in E. Prove that EL equal to twice BL. In the first step, we are going to take two triangles and prove that they are congruent. We'll take this triangle and there's two triangles. That is triangle DEM and triangle MCP, and we prove that they are congruent. Now, to prove these two triangles, the first we are going to use the midpoint. It's given to us that M is the midpoint of CD. So this M is the midpoint of CD. So we have DM equal to MC. DM equal to MC, and this is given. M is midpoint of DC. In the second step, we will take triangle E equal to triangle B, alternate angles. So angle E equal to angle MBC, and the reason is alternate angles. And also triangle, these two triangles will be equal by vertically opposite. So we have angle DME equal to angle BMC, vertically opposite angles. So the triangle DEM congruent to triangle CBM by AAS test. Now we are going to use two CPCTs. One is this CPCT, DE equal to BC by CPCT. So DE equal to BC, that is CPCT. And also this CPCT, we have ME here, CPCT equal to BM by CPCT. So we have ME equal to BM by CPCT. So these two we are going to use later. It's equation 1. I repeat again, we have DE equal to BC by CPCT, and we have BM equal to ME by CPCT. In the next step, we will take triangle AEL and triangle LBC and prove that they are similar. So let's go ahead and prove these two triangles are similar. So we know angle E is equal to angle B, alternate angles. So angle E equal to angle MBC, and the reason is alternate. Next, angle A equal to angle C, also by alternate. So angle EAL equal to angle LCB, alternate. And here we have L equal to L, vertically opposite angles. So angle ALE equal to angle BLC, vertically opposite angles. So the two triangles are now similar, that is triangle ALE is similar to triangle CLB, and if they are similar, the corresponding angles are corresponding sides are proportional. So AL over CL will be equal to LE over LB will be equal to AE over BC. Now we'll just take these two ratios. We'll just do it up here. We know LE over LB equal to AE over BC. So we'll write again LE over LB equal to, now for AE I'm going to write AD plus DE over BC. So this again I will write AD equal to, now DE is also equal to AD. DE is also equal to AD, and why is that so? We know BC equal to AD, opposite angles of parallelogram, and we also know that BC equal to DE by CP CT. We go with that again. So we know DE equal to BC by CP CT. We have proved the two triangles are congruent, and BC is also equal to AD, opposite angles of parallelogram, opposite sides of parallelogram. Therefore, comparing both, I can say AD equal to DE. And the earlier we had two triangles similar. We had these triangles similar. We proved triangle AEL similar to BLC. So let's write that. So triangle AEL is similar to triangle CBL, and then the sides, therefore AE over CB will be equal to EL over BL will be equal to AL over CL. We now do not require AL and CL, so we'll just focus on AE over CB equal to EL over BL. Now look up in the figure and see what is AE equal to. AE equal to AD plus DE. Here we have AE plus DE is AE. So for AE I put AD plus DE over the CB. I write as CB equal to EL over BL. Now even CB equal to AD. So for the CB I'm going to cancel and write here AD, because I know CB equal to AD. Here we have CB equal to AD. Now further here we write AD, and DE is also equal, this DE is also equal to AD. So I write AD over AD equal to EL over BL. So twice AD over AD equal to EL over BL. The AD cuts, so EL over BL equal to 2, which means EL is 2 times BL. We have proved. Just to remind you, in this case here, we have used AD equal to D because they're equal, and BC is also equal to AD. DEFG is a square. So here you have, this is a square. Square means all sides equal, angles 90. And angle BAC is 90. So this angle is given as 90. So we need to prove the triangles are similar. So in the first step, we will take the two triangles AGF and triangle GBD and prove they are similar. Here we're going to do this first. So we'll take triangle AGF and triangle DBG and prove that they're similar. All we have to show is two angles are equal. Now this angle is 90, but it is given to us, angle A, and this angle also will be 90 because it's a part of the, we know D is 90 because it is square. Therefore on the other side also the angle will be 90. We write that first. So angle A equal to angle GDB equal to 90. Now in the next step, you have corresponding angles. Here are corresponding angles because the lines are parallel. These two lines are parallel, the opposite sides of a square. They are parallel, hence the angles are equal. So I will write angle AGF equal to angle B, corresponding angles. Hence the third angle will automatically be equal, and the third angle is angle F will be equal to angle G. So I'll write angle F equal to angle BGD. So the triangles are now similar. So triangle AGF similar to triangle DGB by AAA test. See, we have A, one angle AA. By AAA test, the triangles are similar. This is equation 1. Now next I am going to take we'll now take AGF with angle FEC, these two, and prove that they are similar. So let's write that out. So we have now second part, angle AGF, here this part we're going to prove, and triangle EFC will prove they are similar. So this is 90, angle A is 90, and here this angle is 90, the same reason. So angle A equal to angle FEC equal to 90. Next we'll mark for corresponding angles. Now the corresponding angles would be, if you recollect, we mark this angle in this yellow color. So this angle and C will be equal, corresponding angles. So write angle AFG will be equal to angle C, and that is corresponding. Because the lines are parallel, this line is parallel to this. Hence the third angle, that is angle G, will be equal to angle F. If two angles are equal, the third angle also becomes equal. So this is angle, not triangle, this also is angle. So now we write angle AGF equal to angle EFC. Therefore the two triangles are similar, that is triangle AGF, that is F here, is similar to triangle EFC, again by AA test. Here we'll put equation 1, this is equation 2. So here you have noticed that these three triangles now will be similar to one another. Here in the first we have proved AGF, let's do it darker. We have proved AGF similar to GBD, and now we have proved again AGF is similar to this triangle. So all these three triangles will be similar to one another. If you notice, here is angle, this angle equal to this angle, all 90 degrees. Then next we also showed that these angles were equal. Here these two angles are equal, and again this. So all these three triangles will be similar. Therefore, triangle AGF, one triangle similar to triangle DBG, similar to triangle EFC. Hence I can say that these two triangles are similar. That's triangle DBG similar to triangle EFC. So we have proved triangle DBG is similar to triangle EFC. Let me mark this triangle. We have proved this triangle here is similar to this triangle. So therefore the corresponding sides will be proportional. So DB over EF will equal to BG over FC equal to DG over EC. Now if you know, the inner one is a square, so we have DG equal to DE, and FE is also equal to DE. So wherever there is DG, here DG, I will put DE, and wherever there is FE, I will put here also DE. So what I'm left with now is DB, I don't need this, equal to here EC. And when I cross multiply, I get DB into EC equal to DE into DE. So DB into EC equal to DE square. And the reason for this, we know that FE equal to DE and DG is also equal to DE. These are sides of the square. AD is perpendicular to BC. BD over DA equal to DA over DC. Prove that AB is a right triangle. So we'll start with what is given to us. BD over DA equal to DA over DC. When we cross multiply, we get BD. See, we take this here and here. So we have BD into DC equal to DA into DA. So BD into DC DA square. This is equation 1, and we're going to use it later. In the next step, we will take triangle ABD, this triangle ABD, and we'll take triangle AB, the larger triangle, and prove that they are similar. That is triangle ABD and triangle ABC. We prove that they're similar. If you see, this angle B is common for both. So we have angle B equal to angle B because it is common. Then we have two right angles. Here 90 we won't go about this, we just do something else. We just see, I'll do it again here. This is not right. So we will first take triangle ABD and use Pythagoras theorem in ABD. So triangle ABD, Pythagoras, AB square equal to AD square plus BD square. Next we take up triangle ADC, and this is 90. So using Pythagoras theorem in triangle ADC, we have AC square equal to AD square plus DC square. So this is equation 3 and equation 4. So we add up equation 3 and 4. So add equation 3 and equation 4. So this is equation 3, and now equation 4, AC square equal to AD square plus DC square. And when we add up, we get AB square plus AC square equal to AD plus AD, so it is twice AD square, plus BD square plus DC square. So AB square plus AC square equal to, now we are going to substitute for AD square. If you look up here, AD square was BD into DC. So earlier we saw that AD square was BD into DC. So we write twice for AD square. I'm going to write BD into DC plus BD square plus DC square. Now here this looks like 2AB plus A square plus B square. 2AB A square plus B square is A plus B the whole square. So we'll use this identity. So we have AB square plus AC square equal to BD plus DC the whole square. Look up in the figure and see what is BD plus DC. BD plus DC is nothing but BC. So here I will write BC square. So AB square plus AC square equal to BC square. So by converse of Pythagoras, we can say triangle ABC is a right triangle. Triangle ACB is 90 and CD is perpendicular to AB. We need to prove that CB square over CA square equal to BD over AD. So in the first step, I'm going to take triangle ACD and then the outer triangle AC and prove these triangles are similar. So first step, I take triangle ACD and the larger triangle, that is ACB, and prove that they're similar. If you observe these two triangles, I have angle A that is common for both. So I have angle A equal to angle A, and that is common angle. Then the 90, let's mark the 90. Here I have angle in the smaller triangle, this is 90, and in the larger triangle, this is 90. So let's write that. So angle CDA equal to angle ACB equal to 90. If two angles are equal, the triangles are similar. But we'll write the third angle, and the third angle now for the smaller one is this, will be equal to angle B. So I have angle ACD equal to angle B. Therefore the triangles are similar. Triangle AC, we have write this correspondence correctly. See, remember A was equal to A common. Then we had D, which was 90, equal to C 90 in this case. And then we had C equal to B. So this is the right correspondence. You've got to make sure that your equal angles are written properly. Let me emphasize on this point. So A was equal to A. If you look up in the figure, angle D was 90, here angle C was 90, and then C was equal to B. So we'll write it again. So triangle ADC similar to triangle ACB by AAA test. Therefore AD over AC will be equal to DC over CB will be equal to AC over AB. But here we require AC 2 times, we require AC square. So we have AC square here, and we have AC square here, and we have AC square here. So we do not need this. So we'll now take up AD over AC equal to AC over AB. And when you cross multiply, we'll have AD into AB equal to AC into AC. So AD into AB equal to AC square. This I'll put as equation 1, and I'll need to use it later. In the next step, we will take the triangle, this triangle CDB, and then we will take the outer triangle and prove that they are similar. So we have triangle DCB and triangle ABC, and we will prove similar. So if you look carefully, angle B is common for both the triangles. So angle B equal to angle B, and that is common. Then let's mark the 90. In the smaller triangle, we have angle D is 90, and in the larger triangle, angle C is 90. So we have angle CDB equal to angle ACB. So D equal to B equal to 90. And the third one will be, this is the third angle, will be equal to angle A. So let's write that too. So angle DCB equal to angle A. So remember that C equal to A. Now for the correspondence. So when you're writing the correspondence, if we write B, we write B here. If we write D, see the D is equal to C here. And for the smaller one, C will be equal to A. So this is the right correspondence. This triangle is similar. It's very important to write your correspondence properly. You can check it again and see. B was common. D in the small, this was 90, and the bigger one, C, was 90. If two angles are equal, the third angle also becomes equal. Now the sides. So BD over BC equal to DC over CA equal to BC over BA. Now here I require BC square. So I have BC here and I have BC in this ratio. So I will not take this ratio. So I have BD over BC equal to BC over BA. Cross multiply and I get BD into BA equal to BC into BC, which means BD into BA equal to BC square, equation 2. So in the first I proved that BC square. First we prove not BC, we prove AC square. AC square equal to AB into AD. That was equation 1. And in the second equation we have proved BC square equal to AB into BD. So let's divide now both. So you have AC square equal to AB into AD over BC square is AB into BD. This cancels. AC square over BC square equal to AD over BD. Or you can take reciprocal, BC square over AC square BD over AD. Proved. Two poles of height A and B meters are P meters apart. So here we have one pole AB, A meters, and then we have CD, which is B meters, and they said they are P meters apart. So this is P. Your AC is P. Next is prove that the height of the point of intersection of the line joining the top of each pole to the foot of the opposite pole is AB over A plus B. So I'm going to have join two lines, and those lines are from the top to the foot, from the top to the foot, and both these intersect at O. I have to show that this H, I'm going to find H equal to AB over A plus B. I have to show that this H is equal to AB A plus B. In the first part of the sum, I'm going to take triangle. Here I'm going to take ABC and OL. Now OL we know is parallel to BA. So we have two triangles here. One is this small triangle, this triangle COL, and then we have the large triangle. And we will prove both these triangles are similar. This large triangle will prove that they are similar. So first I take triangle CBA and triangle COL and prove that they are similar. Here I know these two angles are equal because they are corresponding angles, and here also I have angle L equal to angle A because they are corresponding angles. So let me write that. So I have angle B equal to angle COL, and on the other side I have angle A equal to angle CLO, and the reason corresponding angles. Now if two angles are equal, the triangles are similar. So I'll write triangle CBA is similar to triangle COL, and hence the sides CB over CO will be equal to BA over OA equal to CA over, there should be L here, over CL. We do not require these sides, so we'll write it again, BA over OA equal to CA over CL. Now look up and see what is BA. BA is A. O, here again I have to write OL here. This was OL, there's a mistake, and this was also OL. Now OL, if you look up in the figure, is H. Look up in the figure and see what is CA. CA is entire P, that is X plus Y, and CL is X. If you cross multiply, you'll get x equal to ph over a. This is one equation which I will use later. I found the value of x. Now I do the same procedure, but I take another two triangles. I take this large triangle, this triangle, and then I will take the smaller triangle, this triangle, and prove that they are similar. These two triangles, let me write down. The larger triangle is ADC and the smaller triangle is AOL. So you have, again you have L equal to C, and the reason is corresponding angles. So angle C equal to angle ALO 1. Then for the next, we have this angle here equal to this angle, again corresponding angles, that is angle D equal to angle AOL, and reason corresponding angles. So if two angles are equal, the triangles are similar. So I got triangle ATC will be similar to triangle AOL. If the triangles are similar, the corresponding sides are equal. So AD equal to A over AD over AO will be equal to DC over OL equal to AC over AL. Now we don't require this, so we'll write DC over OL equal to AC over AL. Look up and see where is DC. DC is B. Look up in the figure and see what is OL. OL is H. And AC is X plus Y is P, the full thing P. AL is Y. So now Y is equal to HP over F cross multiplied. So I found the value of Y. So in the first triangle I found X equal to PH over A, and then in the next I found Y equal to PH over B. In the next step I am going to do P. We know P equal to X plus Y here. X, this is X plus Y is equal to P. So P equal to, for X I will put PH over A, this value, and for Y I will put PH over B. So we have P, which is X plus Y. I'll take PH common out, 1 over A plus or 1 over B. P will cancel. So now I will have 1 equal to H. I take LCM. AB is LCM, so B plus A. So I will take AB on this side and I take B plus H equal to H. And I have proved. I've just cross multiplied. Let me do that again. So 1 into AB equal to H into B plus A, right? So your H will be AB over B plus A. In the trapezium ABCD, AB is parallel to DC. Here this is parallel, and it's given DC is twice AB. EF drawn parallel to AB cuts AD in F and BC in E such that BE over EC is 3:4. Diagonal DB intersects EF and G. Prove that 7FE equal to 10AB. Let's first start with this part where they said BE over EC is 3/4, which means I can take BE as 3x and EC as 4x. And let me write that. BE is 3x and EC is 4x. Now look up at the triangle BDC, at this large triangle and the inner triangle. These two triangles are similar, so we'll take up triangle BGE and a triangle BDC. We know that angle 1 here equal to this angle 1, corresponding angles, and here we have angle B is common, so the triangles are similar by AA test. So angle B equal to angle B, and then here I write angle, this is angle E, that is B, I'll write it in red. So angle BEG equal to angle BCD, corresponding angles. Hence the third angle also will be equal, that is angle G will be equal to angle D. So we have angle G equal to angle G, we better write in 3 letters. So we have angle BGE will be equal to angle D, also corresponding angles. So the two triangles are similar. Triangle BGE is similar to triangle BDC by AAA test, which means GE over DC will be equal to BE over BC. Let's put the values. GE over DC, we know BE is 3x and BC is 3x plus 4x, and that is 7x. So this is 7x. So this is important. This is equation 1. For the second part, I have 3 parallel lines. I have AB parallel to FE, parallel to DC, and there are 3 transversals. One transversal is BC, and the ratio here I know is 3 over 4. This is 3x and 4x. The other transversal is here, and then we have the third transversal, which is out here. Now if the 3 lines are parallel, that is AB is parallel to FE is parallel to DC, therefore the intercepts also are proportional, which means BE over EC will be equal to BG over GD. This is property of parallel lines, equal to AF over FD. Now B over EG we know is 3x over 4x, which is now equal to BG over GD, which is now equal to AF over FD. So I can say now 3 over 4 equal to BG over GD, and 3 over 4 is also equal to AF over FD. So this is also 3 over 4 ratio, and here too the ratio is 3 over 4. Next step, we will take the triangle, this triangle DFG, and the larger triangle, this larger triangle, and show that they are similar. So we now take triangle, the large triangle DAB, and then the smaller triangle DFG. You write what is common. You have D is common, So you have angle D equal to angle D. Now for the corresponding angles, this angle 1 will be equal to angle 2 because they are corresponding angles. Alright, angle DAB is angle 2 equal to angle 1. And then on this side also we have angle G and B will be equal. So we have angle B, which belongs to the big triangle, equal to angle DGF. These two are corresponding angles. So the triangles now are similar. Triangle DAB similar to triangle DFG. Therefore DA over DF equal to AB over FG equal to DB over DG. We don't require this, so let's write DA. And to remind you, remember this was 4 and this was 3. So DA is 4x and 3x. So this is 4, the DA will be 7x, right? DA will be 4x plus 3x, 7x. And a DF will be 4x equal to AB over FG. So 7 over 4 equal to AB over 7G. So this is my equation 2. Remember the first part we had taken, we proved this, that is GE over DC equal to 7 by 3. Therefore GE will be 7 DC, it was 3 by 7. So GE, let me do this again. So I have GE equal to 3 DC over 7. So GE equal to, if you recollect, well, DC was given as twice AB. So this is 3, and for DC I write twice AB. This is over 7. So GE equal to 6 AB. We also proved in the next slide that AB over FG equal to 7 by 4, which means now F4AB equal to 7FG and FG equal to 4AB over 7. This is important. So our GE, this is GE, and GE is 6 by 7 AB, and here we have FG. FG is 4 by 7 AB. So we're going to add up both these to get our FE. So FE equal to FG plus GE, which is FG we see is 4 by 7 AB and GE is 6 by 7 AB. So to go over it again, we got GE, we prove what 6 AB over 7, and then we have FG, which was 4 AB over 7. So our FE equal to FG plus GE. We'll put the values here. 4 AB over 7 plus 6 AB over 7. So FE equal to LCM is 7, 4AB plus 6AB. So FE 6 plus 7 is 10, 10AB over 7. So cross multiply, 7EF equal to 10AB. We have proved. Just to summarize this was given as 3 and this was given as 4. So then we did what? BE over BC equal to GE over DC, means we have done BE over this entire equal to GE over DC, and then we got 3 over 7 equal to GE over DC. We got 3 by 7 DC equal to GE, and for DC we put AB because DC was equal to twice AB, and this was equal to GE. So we got here 6AB over 7 equal to GE. On the other side, this also was 3 by 4. So here we did DF over DA, that is DF over DA equal to FG over AB. So that he got 4 over 7 equal to FG over AB. And then we found FG as 4AB over 7. So this was 6AB over 7, and on this side here this was 4AB over 7. Then we added it up.